Hello. We are going to work a fluid dynamics example problem. It reads, a pipe carries oil of density 800 kilograms per cubic meter. At point 1, in the piping system, it has a bore area of 0.005 square meters. And the oil flows with a mean velocity of 4 meters per second with a gauge pressure of 800 kilopascals. Point 2 is further along the pipe, and its bore area is 0.002 square meters, and its level is 50 meters above point 1 in the pipe. Calculate the pressure at point 2, neglect frictional effects. Okay, great. So our first thing we're going to do is we're going to talk about continuity. Okay, in continuity equation it says A1 V1 equals A2 V2, where the V's are speed. And we can find out our velocity here. We know that as this necks down, it's going to force there to be more speed here. So we want to, they never told us what our speed there was, so we want to find that. Actually, it might be good to go through and just label stuff here. I got density, I've got A1, V1, P1, A2, height 2, and we want to know pressure 2. Okay, so I'm going to go ahead and diagram this stuff real quick before we get into this stuff. So I'm going to say height 1 is just my 0 height, and so this is going to be my height 2. I'm going to call it 50 meters. Okay, and up here, it's going to be going faster. We're going to call that V2. Over here, it's going to be going slower. We're going to call that V1. There's going to be some pressure right here. We'll call that P1. There's going to be some pressure against the flow right here. We'll call that P2. And I think, let's call this A1 right here, and let's call this A2 right here. All right, I think that's everything we've got. Okay, so we don't know this guy, and we don't know speed 2. Okay, so let's look at our continuity equation. Maybe we can figure out that speed 2 here. So that's going to be speed 1, A1 over A2 stuff. And if we put our numbers for that, speed 2 is going to be equal to 4 times 0.005 over 0.002, and when we crunch the numbers, we get 10 meters per second out of that stuff for V2. That's not an answer, but boy, it's going to be sure helpful when we get to do our our Bernoulli equation. So for part B, we're going to do Bernoulli, and basically that says this fluid flow has got to abide by the conservation of energy. So we're going to go ahead and write out our Bernoulli equation. Give me just a second. P1 plus rho GH1 plus 1/2 rho V1 squared equals P2 plus rho GH2 plus 1/2 rho V2 squared. Whew. Okay. There's our Bernoulli equation. And let's just go ahead and see if we can cancel out some things here. So, yeah. Basically, we said height 1 is going to be 0, so that gets rid of that term. And we got to keep everything else. That's okay. All right, so I'm just going to put in some numbers here that we're given. So I have 800 e to the third for 800 kilopascals, plus 1/2, 800 is our density, times 4 squared equals P2 that we're looking for, plus 800 for our density, 9.8. Our height is 50 higher, and 1/2, 800 for our density, and we figured out that this was 10 meters per second. We're going to square that guy. And then you do some math, and you can get pressure 2 is going to be 374.4 kilopascals, or 374,400 pascals. And let's think about this. So we know our energy, what we're going to be going faster at position 2, we're going to be higher up. How do we make that happen? We got to have a higher pressure down here than we have up here to make it gain that energy when it goes up to the top part. And so I like that we have pressure 2 is less than pressure 1. That is like good times right there, my friends. So that makes a lot of sense. Okay, so basically we had fluid flow through a pipe. It restricted down right away. We know we can do continuity equation to figure out this missing velocity they didn't tell us. So for this fluid flow, we didn't know pressure and we didn't know velocity. We need 2 equations for that. So our first equation we used was continuity to find the velocity. That got us something here. So we didn't know that initially, so we're good there now. And we didn't know pressure, and so we used our second equation of Bernoulli, and then we could solve. We took this and put it in here, and we have one equation, one unknown now, and we can solve for our stuff. All right, hopefully that gives you an insight how to use continuity equation along with Bernoulli to solve for stuff about a fluid flow. Thanks, everybody.